Okay, I'm recording.
It is speculated that fire was discovered when a babbling caveman struck two rocks together, forever changing our future. We all use fire at some point, and in most cases every day. Whether you are cooking your food, heating your water for your home, or lighting a candle, we utilize this element. We all utilize this element. Today I'd like to show you some of the basics of fire and how it works, so you can have a better understanding of it. What is fire? Some might say that it's the sparkling hot stuff that we use to light our stove when we're getting hungry. I do. Although that is true, let's look a lot closer at a better description of what fire is. Fire is an exothermic reaction created by the breaking of molecular bonds, producing light and heat that our eyes and other senses perceive as fire. Anything that has the ability to burn is considered a fuel. There are many different types of fuels. Wood, fibers, and combustible liquids are a few examples. These fuels can come in three different forms: gas, liquid, and solid. Traditionally, we are taught that fire must have three key components to sustain itself. We know this as the fire triangle. We have to have oxygen, heat, and fuel to sustain fire. This is the really old version of what people used to be taught. Now, due to scientific research and all the data we've gathered over the years, that's kind of changed. We have a new addition to it. We have oxygen, heat, and fuel still, but we have sustained chemical reaction in the middle. If you lose any one of these three, your fire's out. Now let's talk about off-gassing. I'm not talking about what you do in the bathroom. Off-gassing is when a substance is heated and the molecules that are burned off of it come outward and aren't completely burned, and they float off into the atmosphere. This off gas and this unburnt particles can still burn because they're still hot, but if they're put out, if the fire's put out and then if you put fire back onto it, it'll start the process back over again. Let me show you. You can see the smoke rising up, and if you get fire close to it, it'll come back down. Oh, did you see it?
Yep.
It will jump from the unburnt particles back down to the fuel source. Let's see if I can do it again. See it?
That's crazy.
It's a common misconception that the substance itself burns. This is where the off-gassing comes in. If you observe closely, just throw it. If you observe closely, whenever something's burning, it never actually touches the surface. It gets really close, but it's always hovering right above the surface. The reason being is because the off-gas is actually, the fuel is heated and the off-gas comes off, and the gas itself is what actually burns, not the substance itself. Generally on Earth, how does fire move? It either moves naturally or it moves whenever another source acts on it. Generally, on Earth, fire tends to grow outwards and upwards. This is due to the science of fire in relation to the atmospheric pressure of Earth and our oxygen content. When a substance burns, it does not burn at all. When a substance burns, not all the gases burn themselves. These are called superheated gases, or unburnt particles, or smoke for short. These little bits of superheated gases and unburnt particles are parts of molecules that haven't completely finished the exothermic process. Although they did not complete the process, they did still absorb a lot of heat, which causes them to be lighter than air and rise upwards like we saw earlier. Let's talk about the different methods of how to heat an object. There are four basic methods to heat an object: mechanical, electrical, chemical, and nuclear. Mechanical heating is heat that's created by friction. When two surfaces are rubbed against each other, they create friction, thus creating heat. The roughness between the two surfaces will greatly determine the outcome of how much heat is produced. Electrical heating is one of the most common we see today. There are two types of electricity that's utilized: alternating current and direct current. For this speech, I'll be speaking about alternating current. When electricity is introduced to a metal, the electrons are transferred through the metal from a positive end to a negative end. All metals have a certain electrical conductivity and resistivity rating. Whenever a metal has a high resistance rating and a surge of electricity larger than is able to go through it, successfully goes through it, it can heat the metal, which is a common cause of house fires in the United States today. Chemical heating is created when one or more substance creates an exothermic reaction. This form of heat is not as common as mechanical or electrical. However, it is known to be the cause of many fires in automechanical, carpentry, and hobby shops, such as oil. If you leave oil out and it's spread out enough and it gets enough oxygen, it can actually produce heat on its own through this chemical reaction and create a fire without you having to do anything to it. The last way to create heat is through nuclear energy. This heat is created by radioactive materials commonly used in reactors to create electricity or for scientific research. This form of heat creation is very uncommon in everyday applications. Now, there are three modes of heat transfer: conduction, convection, and radiation. Conduction is heat that's transferred through an object. An example would be a fire that's on one side of a door. You can feel the heat from the fire through the door, more especially through the handle because it's metal. It's very common conduction heat is very common in electrical fires. Convection heat is the movement of heat through liquids or gases, more commonly gases. We commonly see this form of heat transfer in ovens. The heating of an element causes the heat to rise and form in the form of a superheated gas and fill a compartment such as the insulated oven compartment. When the door is open, superheated gases will move with the path of least resistance and come out and up. The last mode of heat transfer is radiation or radiant heat. This is the most interesting one to me. Radiation heat is transferred through the form of electromagnetic waves in all directions through the air. The heat you feel when standing next to a hot object, such as a wood-burning stove or a regular heater stove, is what you feel as the radiation heat. The interesting science behind radiant heat is that it can be transferred in all directions from an object using electromagnetic waves. Alright, let's talk a little bit about the science behind fire. As I said earlier, fire is the breaking of molecular bonds. When an object is heated by any of the various means, the bonds between molecules break apart, creating light and heat. This is what our sense of sight and touch perceive as flame. When these molecules break down into smaller individual parts, in a simple way, they let go. These particles will be forced away from the object and in an upward and outward motion, partly because the gases are superheated and they're lighter than air. The heat produced from the breaking of molecular bonds will cause the molecules around it to do the same. This is called the domino effect, which allows fire to move along a surface. Fire will not skip over molecules. Well, it won't skip over molecules, but it can go around. But usually we do not see this. It will move from one molecular bond to the next until acted upon by a suppressive force like water or CO2 or different types of suppression forces. Now I want to talk about a solid versus gas. Why do they burn differently? The two main things to consider with solid and gases is one, what's the ignition temperature of the molecules, and how condensed are the molecules in the substance. Simply put, a solid is a group of many molecules compressed together to create a solid structure. Let's take wood for instance. Wood molecules are very close together and generally have a very low ignition temperature. Since the molecules are so dense, however, it takes longer for the fire to move along the surface and burn all the molecules. That's why you can burn a piece of wood for a long time. And the gases, the molecules are further apart, but they have a very low ignition temperature. So that's why the gas, whenever the fire hits a gas, it shoots across the gas real fast. Fire is an interesting yet destructive chemical reaction that we all utilize in some form. Whether it's convection, conduction, radiation, we all benefit from fire at some point. Many things can contain it, and many things also provoke it. Although fire was discovered a long time ago, we are always and constantly learning from it. If we learn a little bit about how it works and a little bit about fire safety, we will definitely live in a safer world than we do today.